Okay, a very good morning once again. Hope I'm loud and clear. Should we start? All right. So the course title is Applied Machine Learning, right? Before I even start with it, what is your understanding of machine learning? You can unmute yourself and just whatever is your understanding of machine learning, right? You can say a few words about that. I come to know, okay, you don't have any prior experience, but I think this has been a buzzword in the industry for a very long time now. So you must have heard this word, right? You must have heard certain projects. So what is your understanding?
Good morning, sir.
Good morning.
So, my understanding is machine learning is writing some algorithms
Hmm.
and some programs in which you train like the algorithm to perform a certain task or set up a
Hmm.
baseline, and according to that, it perform like it. You train the model to do some to set up a baseline and then to do something based on that.
Okay, you said some baseline, some training. These are the two words I can sense out of it. Okay. Any other candidate? Please, this is a dialogue, right? So whatever is your understanding, you can convey at this moment. We will further refine it. Nobody want to answer what is machine learning? What is your understanding of machine learning? What happened? Yeah, please go ahead.
Yeah. So, sir, I am really not sure about the answer, but
It's
as
okay.
Ali told, we train models using data. So
Hmm.
maybe machine learning um, helps the system to understand the data and helps the user to take a decision or make a prediction about
Hmm.
uh, the outcome.
Okay. Some words which you are saying, I'm just writing. Fine. Any other candidate?
Good morning, sir.
Yeah, good morning.
Yes, sir. My understanding of machine learning is like till now, before machine learning, if you want to make the computer learn anything, we have to explicitly program it. But for machine learning, without programming it can learn from the data we provided, like the
Hmm.
training data.
Hmm. So very important point. Learn from data. Anything else? Anybody else who would like to answer? Oh,
Yeah, good morning, sir.
good
Uh, what
morning.
what I know from the very top level is that we are basically writing a piece of code,
Hmm.
and we are feeding some data and we are training a model. and
Hmm.
which is helping us to make decision or predictions about the future or the new data we are giving it as an input.
New data that we are giving it. Okay. Train on data and then predictions on new data, right? Rather, I should use the word unseen data, right? Okay, good inputs overall. You have some understanding, right? We will refine it a bit. Some of you have given very good words like learning from the data. That's very, very important. Training on a data and predicting on unseen data. That's another very, very important point. Why we are doing so? So that we can take correct decisions, right? That's another words you have already given me. How do we do it? We train a model, right? How do we train it? That's altogether a different ball game, right? So we will look into those details also, how to train a model and so on. Nothing like very complex programming that we are going to do, just library calls that will make our job easy. So if we are well versed with Python, right, then our job will be easy. How many of you have worked with Python?
I have worked, but not in like past, recent past. Like
Oh,
it's, I have to revise things. And
revise the things. Okay, but you have some hands-on experience with Python. Okay, Ali has
yes,
worked with Python. Anybody else? If you haven't worked, please put no, you haven't worked with Python so that I can come to know how many of you have not worked with Python. Know the basics of it. Good. Okay. Shweta said no. Know the basics. Okay. Which Python editor you have used? VS Code idle. Okay. VS Code. All of you have worked with VS Code. Okay. So people who Google Colab, that's good. It's a browser-based platform, right? So I was about to tell that people who know some basics of Python, they should explore alternate tools like Google Colab and Jupyter Notebook, which makes which will make our job a little more easy, right? You're free to use any one, but prefer I would prefer okay if you can use Google Colab or Jupyter Notebook as such. People who haven't worked, right? They can also start working with Python. Start with a basic program writing a hello world job, right? Just print hello world. Just see the look and feel, how to compile, how to run, and all those things. Try some if else statements, try some looping statements. All of you know C programming very well, Java programming very well, right? Maybe a little bit syntactical difference will be there, but my humble request would be not to copy paste the programs from the internet, learn the syntax, write it, and practice it so that you are little well versed with the Python environments, right? The experiential learning part, once we learn some basic concept, we will start, and along the sessions, we might do some experiential learning. Once you're well versed with the basics of Python, right? And then the next step would be to explore some data science libraries, right? Machine learning data science libraries. But and in the first week, what you can do is people who are already well versed with Python, they can spend 2-3 hours and just do a refresher of that. People who have never worked on Python, I would request all of you to spend at least 4 to 5 hours, right? Get well versed with all the basic fundamentals, if else statement, writing a function and all. It's common across all programming languages. And that will help you out to further gain the insights into the library calls and all. So once you are well versed with that, it will make your job easy further to understand, right? So that few things that I wanted to give you initial heads up on that. So start it from today only, right? Google Colab, no installation required, nothing required. Just see how to launch Google Colab and start writing code. Okay. Jupyter Notebook, you need to install Python and Anaconda framework and all those things, right? So for that, you will need some installations and you can do that also. It's not a very hard job. Within 15-20 minutes, it will be over and then you can launch your Jupyter Notebook. Okay. Now moving ahead, related to the course content as such. So what we will cover, right? So we have around 10 modules in this course. All of you have access to handout or not? Do you guys have access to handout or not? No. Okay. Is the course page there on the eLearn portal? Anyway, okay. So just check it later on. So let me go through the syllabus, right? What we have in this course as such. So the syllabus is divided into 10 modules through M1 to M10, right? So what in module 1, what we will cover as such? We will introduce the fundamentals of machine learning, including what is machine learning, why it is important, and its applications. We will look into the types of machine learning, some challenges associated with it, and this particular module will help you to find out to build a conceptual foundation before we move into the practical aspects of machine learning, right? This is very, very important. Some of those contents I'm going to take up in today's sessions. When it comes to module 2, now in module 2, the course will shift towards applied understanding with real world context, right? Which will focus on the big picture on end-to-end machine learning, where you will learn how to frame a machine learning problem and work with data through pre-processing as well as visualization. So what happens typically is in real world scenario, the data which we deal with, right, it has a lot of quality issues. What are those quality issues? We will discuss in detail, right? If I'm going to work with some data I've got, right, I cannot directly feed it to any model for training or any algorithm for training as such. I need to first do a pre-processing. Maybe I need to clean the data, right? When I say cleaning the data, there could be so many things that are missing in the data as such. So that sort of pre-processing is required before I actually use this data for model training. Right? Then another thing is, let's say, let's take an example of customer churn. This is typically in telecom industry, right? We must have also done ourselves as well. Today, some A company is offering some plan, right? Tomorrow, some B company comes with that plan with a lower price value, we shift it. And that's what is called as a customer churn. We are moving from one particular vendor to the other vendor, right? So each of these vendors, they want to do the churn prediction. How many customers will stay and how many customers will leave, right? If I want this kind of a problem to be solved, that how many customers will leave, right? Probably I can make use of machine learning given certain kind of customer data, like uh, it could be the demographics data, right? Customer demographics data. But can I use that customer data as such in the form as it is available? It could be possible. Some of the customer details are missing. Some of those details are recorded incorrectly, right? Maybe that company has multiple stores and each store is storing the data in a different format, right? So I cannot use that data, right? I want to do a churn prediction, but the data available with me, I cannot use it directly. So first we have to understand what are the challenges, what are the quality issues that exist within the data, right? And then we should learn how to handle them, like how to handle with some missing values within the data. How do I standardize the formats, right? So all these things we will cover in module 2. Right? Then module 3. Here we will introduce model selection, training and evaluation, where we will learn to choose an appropriate models for prediction tasks. What could be the prediction task? It could be, let's say I want to predict the house prices, right? Or I want to predict whether an email that is there with in my account, should I label it as a genuine email or a spam email, right? So which particular model should I pick up given a particular problem in hand? That is what we are going to learn at a high level. Further, what is important? It's not only important to pick a particular you can say a model or a particular algorithm to solve a problem, right? I need to have some evaluation metrics in place. Now the model is making some predictions. How accurately it is making those predictions? So before deploying that model for unseen data, I should do some form of testing, right? I should track certain evaluation metrics. Maybe those could be in the form of accuracy. As we will progress, we will learn some more evaluation metrics, especially with classification problems, where we will see accuracy is not only measure as such, rather there are more important measures in terms of precision, recall, and F1 score, right? So these are the new terms that will come, right? So maybe if you don't know, don't worry at this moment. At a later stage, we are going to talk about it in detail, right? With examples as such. So there will be some mathematics that you can expect, not some, I mean a lot of mathematics that you can expect in this course, right? Module 4 will focus on the prediction models, linear prediction models, right? Where the students as such, participants, right, will explore the linear regression and optimization techniques. When I say optimization, there's one very, very important algorithm known as gradient descent, right? And there are variants of gradient descent as such. When I want to predict a house price, right, I am predicting some value. I want to predict a stock price. I am predicting some numerical values. All these are regression problems, right? But what I need is I need some data, right? Suppose I want to predict a house price. So model should learn based on certain features that will be there within the data. That features could be the area of the house, right? The locality of the house, the number of rooms within the house, whether the house is marble flooring or not, whether the kitchen is modular or not. So all these will be the input features basis which we can predict the house price, right? How to do that? That we will take later on, right? Further, within this particular module, we will look into the concepts like regularization and bias variance trade-off, right? We will, these are the some new terms. I don't want to go into the details at this moment, but these are the terms that are very, very important uh, when we build typically the regression models, right? Then comes this module 5, which we'll introduce some classification models, and the popular ones are the logistic regression, right? Support vector machine, naive-based classifier, and we will do the comparative analysis of all these classifiers, right? Then within module 6, we will further advance our classification techniques, right? We will talk about decision trees, which are simple to understand, right? And we will look into what are the challenges associated with the decision trees, and gradually we'll move on to the ensemble methods, right? What are these? This is again a new term. Let us not discuss too much in detail, but yes, what is ensemble? We will talk about it in detail. Then there are other techniques like bagging, boosting. Uh, these are the techniques we use in a simpler way, I can say, to make the models more stable and robust, we use these techniques, right? These are the two lines I will mention at this moment. But these two techniques, again, we will cover with the help of examples. And there will be one more advanced algorithm that we will look into in classification is the random forest, which is nothing but it combines multiple decision trees to kind of improve the prediction accuracy. In module 7, we will look into something known as unsupervised learning, right? So whatever the prediction, the regression model and the classification model, right, that we said, they are supervised learning techniques. While in module 7, we will start with unsupervised learning. Now, what is the difference between the two? That we will cover in today's session, right? So the important techniques that comes under unsupervised learning is k-means clustering. So clustering is one of the technique, right? So we will look into k-means clustering, some EM algorithms, their applications, right? That is what we will do in module 7. In module 8, we will look into neural networks, which starts with the basic perceptrons and will move to the multi-layer networks as well as back propagation. So we'll use examples like maybe how to recognize handwritten digits as such. So how to solve that problem using neural networks, right? We will also look into some foundations of deep learning within this particular module. Right? So module 9, we will look into deep networks, including this very important name CNN. If you search on Google, right, convolution neural networks, typically used for image processing, right? So then we will also look into recurrent neural networks and their applications, as I mentioned, in image and text processing, right? The last module, right, addresses certain problems such as fairness, accountability, and transparency in machine learning. Now, what happens when you train a model? You say it is making some predictions. Now, what is the basis of that prediction? Right? Is there any reasoning behind that? So that is where this fact machine learning will come into picture, right? So interpretability as well as transparency. These are the two important terms in module 10 that we are going to cover. Right. So these are the last one, which is mentioned as robustness and adversarial attacks, right? These are again the new terms. As they will arrive in our course, we will look into them in detail. So there are many terms which we have talked about as per the syllabus, but many of these terms, right, might be new to you. So even if you don't know at this moment, it is fine. But as we progress in this session, right, session by session, these terms will be introduced to you with examples, And my humble request would be you to you is spend some time on every session, and this is going to be very valuable course overall. Right? Every hands-on will be on Jupyter and those Python notebooks, right? Jupyter notebooks. Jupyter notebook, in a Jupyter notebook, the Python is already there as such. You just need to write the code, execute it, and you'll see the outputs there. You can write theory also, you can write comments also. It's very easy to maintain a Jupyter notebook, right? And you will see, okay, everything can be maintained within a single that ID Jupyter notebook as such. Now, moving on further, what are the books that we will look into, right? And the first section is the textbook section, second is the reference book, right? So the textbook first is Hands-on on Machine Learning with Scikit-learn by Aurelie Publishers, right? So this book is widely used for practical hands-on understanding of the machine learning concepts as well as their implementation, which will help you to connect theory with practice, I would say. And that's the objective of largely this particular course. And second is Introduction to Data Mining by Stenbeck and Vipin Kumar. This is again a very, very popular book which will help you to found strong theoretical foundations, uh, specifically in data mining concepts, um, as well as the algorithms and some more analytical techniques that we are going to use. So these two will be our textbooks. Then another section comes with the reference books. There is one chapter we said, right? The last one, the module, fact machine learning, fair, accountable, transparent, right? So the reference book one, interpretable machine learning, right, by Christoph. There's also a link which is mentioned as such, where this interpretable ML book might be available, right? You can just visit this link and see if that book is available or not. So the content of that particular module will take it from this particular book, that what is the reasoning behind a particular prediction, how to interpret it, right? And another reference book which we will use is it's not a book, I would say. It's a paper that you can see a few useful things to know about machine learning. So communications of the ECM volume this so and so. That's a journal paper, right? Which will provide the practical insights and guiding principles about the machine learning that may not be very obvious, but these things that this paper is going to describe, right? They will be highly valuable in the practice. We will go through it, right? Regarding evaluation scheme, before I move forward, right? All of you know that there are three components, EC1, EC2, EC3. The details of EC1 component, I'll make it available as soon as I finalize it. Some discussions are going on, right? So, but 30% weightage will be there for the EC1 component. It will comprise of quizzes, the assignments, maybe some lab component, lab sheet component, or there's one more component that we will introduce is situated learning, right? That I will talk about that situated learning assessment later, right? But it will be a part of EC1 component. All of you are expected to do that with diligence. EC2 and EC3 you already know, right? Mid-semester examination and comprehensive, mid-semester closed book, comprehensive open book exam, and the weightage will be respectively 30 and 40%. Okay, so that's all about the course. And now we are going to start with session one, introduction to machine learning, what, why, applications, types of machine learning, challenges, all that we will look into it, right? This is chapter one of textbook, right? Anything that you would like to know before I move ahead? Should we proceed then? Hello, am I audible? Okay, so please keep
Yes,
responding,
sir.
right? Yeah. Wherever you feel okay, you're not able to follow, do let me know. What is machine learning, right? You already told me many things, right? When we started the session, right? What is machine learning? What is your understanding of machine learning? You talked about something known as there is some data. Using that data, we train the model and so on, right? And that model will give us some predictions using which we can take decisions. So it helps us in better decision making. That's what typically we said. So far, what we have been doing. Okay, before whatever the courses that you've learned or whatever the roles in which you are placed, if you are working with some algorithms and all, what is a typical scenario? You write a program, you give the input, you get the output, right? This is what we have been doing.
Yes, sir.
Just a minute, I'm just searching for, yeah, okay. Yeah. So you have an input that is given to, let's say, a program, and you get an output. So far the major focus was on writing the program. How to solve that, how to take that input, how to process it, how to get the desired output. That is what we did, right? Now, what will happen with machine learning? Any idea? When I train a machine, what does it mean?
Allowing the system to learn the data.
Allowing the system to learn the data. Okay. When you say learn the data, what do we mean by that? Learning data. It knows what to do once trained. Okay. So when we are doing that training, what we are doing? What we are doing when we are doing the training, what we are doing exactly? So basically, when I say you have trained a model, right? What is a model here? Any example of a model? Okay, there are some answers written. We are inputting some data and the model, the code which we write, it understands the data. Patterns, correlation, and again, that's very, very important. So it learns certain patterns, some relationships within the data, right? That is what is expected from a machine to do. We are not feeding uh, a specific set of instructions, right? We are giving a data and we are asking, okay, this is the kind of a problem it is, and you learn some patterns out of it. Once it has learned certain patterns, using those patterns or using those rules, you can say, it is going to make predictions. It learns from the given input and output, and then from this machine, given input and output. That's also very, very important. So basis this, we will talk about the types of machine learning. Okay, so that's one aspect of it. What is machine learning? Why machine learning? Why machine learning? Why we need machine learning?
Need for intelligent decision making.
Intelligent decision making. Okay. So what kind of problems I was not able to solve by writing a program?
Speech recognition or image recognition,
Speech recognition, image. Okay.
which is like very hard to
Hard to
ma
what? Yeah.
mathematically, I mean, to train, I mean, it's very complex mathematics to
Hmm.
train a system. So maybe that's why we are using machine learning as a
Okay.
base.
Okay. Okay, I want to find out largest of two numbers. Should I go and write machine learning, use machine learning for that? If I want to find largest of two numbers, largest of three numbers, we can use a normal programming. I want to sort the numbers. I can use normal programming, right? Now imagine all of you going, all of you must have visited or you are visiting office on daily basis, right? Yes or no? Now the problem in hand is, okay, there is a distance from some distance from where you start and where your office is, right? And you say, okay, this is the normal speed that I'll go with. And I can say, okay, this is the speed, this is the distance, and this much time it will take to reach office, right? If things are so simple, I can write a program and say, okay, by this time I'll reach office. But actually, there are a lot of other variables that are influencing it. What is the traffic on the road, right? How is the weather today overall, right? Is there any special event going on in the city or so on, right? So looking at all those aspects, we cannot come up with simple if then else rules and say, okay, I will be able to reach office by this time. So what I need is I need the data overall. What I need is I need the data. What sort of data I need? So maybe I must have, let's say, last 2 year data with me when I've traveled from this place to this place, along with this is the time taken, right? That much data I have. Maybe I have a data of around maybe 1 lakh trips with me from home to office, and this is the time taken. Now, with some features will be there, okay, this was the day, there was any special event, yes or no, what was, right? And all those things will be there. Now, when this data will be fed, right, to the machine, then machine will learn certain models and all. And when you say, okay, now I want to predict tomorrow how much time it will take, right? then machine has learned certain patterns. So machine will see, okay, what is tomorrow's date, right? It is a week. Is it a weekday or a weekend, right? Of course, on weekends, the traffic is less in metro cities and movement is very fast, right? So is it a public holiday or not, right? Is there any special event? Maybe some minister is coming to the city, right? Maybe there will be high security, some roads will be blocked and so on. So it will consider all those things and then make a prediction. So it is very hard to come up with if then else rules and say, okay, if this is the case, okay, this much time it is going to take. Then what we do, let the machine learn from the data, and machine will learn its own patterns. And once it has learned, it can predict on the unseen data. Unseen means which is it has not seen yet. If I say, okay, tomorrow I want to predict what will be my travel time to office, right? So it will give me that data. Is it making sense why we are doing machine learning? Some problems straightforward. We can write a perfect program and get the perfect output. But we are using machine learning for those where we are not expecting a perfect output, but an optimized solution to that. I'll never say, okay, 100 on 100 accuracy I'm getting, right? Maybe in some cases I'll get right, but that is not the expectation. Otherwise, if that 100% thing I am able to achieve, right? If sorting is a problem, right? I am know that by writing a quick sort or writing a merge sort, 100% result I'll get, all the elements will get sorted. There is no need of doing using machine learning on that. I hope it is making sense. So far, we have not gone to the formal definitions of what is machine learning, right? But at a higher level discussion with examples, I'm trying to explain why machine learning. Third point says is connection with other technical areas. What does it mean? Any thoughts? So it simply means that it's not an isolated field. That okay, this is what machine learning as such is, and it is not related with anything else, right? Rather, it is very closely related with areas like one is statistics for analysis that which we are doing. Another thing is some mathematics like linear algebra for mathematical representation, optimizations for model training, and of course the computer science writing a program for implementation. Or it's a mixture of all these. That is what makes a machine learning overall, right? So it borrows something from stats, something from mathematics, the topics like linear algebra, optimization, and of course programming, computer science to implement that. That is for that we are going to use Python as such, right? So this is about machine learning. Now let's look at an example. What this a diagram or the snapshot indicates is what it indicates. All of you must have seen, right? You are you are also using it. So in your mailbox, you have two important aspects, right? There are emails coming to your inbox. There are emails that sometimes go to spam. Right? Good spam detection system, correct? So when the emails are coming to your account, right? Either they go into inbox or they go into the spam. Are you explicitly putting them that this email should go to this and this email should go to this? You are not doing it, right? Automatically, either the email goes to the inbox or to the spam, and later on you can do some organization as such, right? That option is there. Gmail decides automatically, correct? How does it decide? How does it decide? There should be a way to decide that. So can I simply say, okay, if it is coming from this vendor, I can simply call it as a spam, right? Can it be a sender based, right? Could be in certain cases, but could not be in all the cases. So what we need is, in order to do this kind of a classification, whether the email is a genuine email or a spam email, if I want to make it as sort of a machine learning problem, right? What I need is the data, some historical data. So there will be some input features in the email from where it has come. It knows based on the historical emails, correct? So that historical emails are actually the data for the machine learning model. So using that data, it will learn the characteristics of a genuine email. It will also learn the characteristics and the features of a spam email. Now you give any email, new email to it, it will try to classify it either as a genuine or a spam or not spam, basically, right? So what typically you see, most of the promotional emails, right? There you These are the emails which you will find in spam, right? They might have words like a free credit card, let's say, right? Or this can be written in some different way also. But my machine should be able to recognize, my model should be able to recognize this. Only then it can classify. If I simply say, okay, if there is a word free credit card, move it to spam. Now, if this is written in some different way, my program will not be able to detect it, right? But if I give a machine learning algorithm or machine learning model, it will check for sort of certain patterns, right, within that email. And then using that patterns, if those patterns are identified, it will classify it as a spam or a genuine one. You must have seen now on the phone calls, even these telecommunication vendors have also started this service. Whenever there is a phone call, right? So many a times now it is alerting this could be a spam call. Have you seen that?
Yes, sir. It's a spam alert from Geo or from Airtel like that.
Yeah, it gives you some, right? So by simply making a one or the other call, it does not become a spam. There are a lot of things that this number from that number might have happened, and they might have tracked it, and some characteristics might have been understood, and then they are calling it as this the spam number. So it is all with the help of data that it is able to do this, right? This kind of a classification. So this can be a very simplistic or example of a machine learning, that if I want to classify my emails as spam or not spam, let's have an historical data of emails which should have both spam category and non-spam category, right? Then once you feed it to the model will say, okay, these are the characteristics of a spam email, these are the characteristics of not spam email, and those patterns are learned now. Once you feed another email, right, new email coming to your inbox, right, or to your account, right, it will be able to fetch its features and see the patterns within it. If it is matching with a genuine email, it will move the email to the inbox. If it is matching with a spam email, it will move to the spam. That is how it works. Make sense? With this example, are you able to understand? Do you still think that, okay, we can write some if then and else rules and still say, okay, this email can be, I mean, writing a program only that you can say, okay, this is email is a spam and this is a not spam. Do you still think? No. Because writing as such rules, right, will be very, very complex. Program cannot evolve as easily as ML, correct? So let's say the pattern of those spam emails may be changed later on, but that changed data, you feed it to the ML model, retrain it, and then it will sort of learn that also the new features of those spam emails, and then it will be able to detect those new patterns that exist within the spam email. Okay, now moving ahead. Now, this is one of the formal definitions given by one of the authors, right, Arthur Samuel. It states that machine learning is a field of study that gives the computers the ability to learn without explicitly being programmed. So I'm not feeding a program, rather, it learns out of data. That program or the patterns, whatever it is, right? It learns out of the data. That is that is what is machine learning. And you see, this definition was, this is a very old concept, 1959. So conceptually, this particular term, machine learning, exists. If you see now, it's almost 65 years back, right? But why suddenly it got popular in the last decade? 2012-13 onwards, this term got popular in industry. Why so? Any idea? Why this term got popular recently? Why it was not popular in 1960s? Though the concept was in existence at that moment. Yes, maybe the amount of data increased, which programming alone could not handle. Okay. Anything else? Due to big data? Okay. Evolution of hardware. That's very, very important. Evolution of hardware, right? Both the things are important, right? What we need for machine learning? We need data, right? One part which we need is data. Another part we need is the computations. Neither did that much data was available, because with a very small amount of data, you cannot expect a good accuracy or good performance out of a machine learning model. So in 1960s, hardly data was there, but nowadays you see how much data do exist and the pace at which it is growing, right? So a lot of data has become available. Additionally, the hardware cost has gone down. When I say hardware, it's all about storing the data somewhere, processing it, right? That cost of computation has gone down over a period of time. So now we have a good amount of data to train a model, as well as the computation power, as well as the storage capabilities, right? All three we have right now. So that's what is making machine learning a practical thing. Right? So that's how it has evolved right now, not in 1960s or maybe even 1980s or 1980s, no. Because evolution of hardware is because of this computation cost and well as the storage cost, which has gone down, and that's how we are able to actually proceed with these machine learning. Yeah. Now let us look at few more examples, right? We have already talked about the first example, that I can categorize or classify the emails as spam or non-spam, right? So input is an email, output is a spam, right? 0 or 1. So we are doing some sort of spam filtering. That's one example of machine learning, right? Another few examples that are, one is I'm going to do a translation, machine translation, right? When you say machine translation, it means converting the content of one language to the other. Now, the language here given are English and uh, Hindi, right? So I'm going to give my input text in English and the output is the translation into Hindi, right? Which demonstrates machine translation. And of course, there are systems like you must have seen Google Translate. So what typically we do here is model learns language patterns from the large data sets that we provide, right? So what we will feed is, this is the English content, this is the Hindi content, right? Corresponding Hindi content. We will feed it to the model. Model will learn certain patterns out of it, right? And once those patterns are learned, right, we can, once those patterns are learned, then you can feed it on to some unseen data, some new paragraph of English you can give, it will translate it into Hindi. That is how it happens. Right? There are other examples like you give input as an audio and you want a text transcripts, right? This is known as a speech recognition. Now, this audio may be, different people may have different pronunciations, right? So you feed that data that these are the pronunciations that may come across, and this is actually the text, right? Once you have fed enough data, right, model will learn certain rules and patterns out of it, and you can easily generate a text then, right? Model will say, get a new audio and it will generate a text out of it, and this is known as speech recognition. You must have worked with all these applications by now. This audio transcript, right? It is happening in probably every session that we as a faculty are conducting, right? You get transcripts out of it. So what is it? Audio text transcripts, right? This is a speech recognition. I hope it is making sense. Yes or no? So this is just all these things I'm showing that so that you can understand, right? Very, very simple session today. There are medical images, right? Now, what typically we do, whenever you get a medical test done, you go to the doctor and doctor will visualize that and then say comment about it, right? Or there are machines using which they write, okay, this organ is not in appropriate shape and something like that, right? Or there is something seen here in this particular area of your body and all when you go for a CT scan or MRI or maybe an X-ray even, right? So now let's say the output is to find out whether there's a tumor or not. So what is it? You feed a medical image. Now the machine learning model should predict whether there's a tumor that exists within this image or not. Normally it is done using a visual inspection by the doctor. But what you can do, we can train a model by feeding a large set of images, medical images, which has a tumor and which do not have a tumor. Then model will learn certain patterns out of it, and then you feed a new medical image, it will detect, okay, whether there is a tumor or not. The last example is it happens in sort of autonomous driving. So what you feed as an input is images and radar data, which are processed to determine the position of car and objects, which kind of enables self-driving systems to make real-time decisions. So all those images you put into a model, output is what the position of the cars is, and this application can help in self-driving autonomous vehicles as such. So these are few examples, right? My humble request is you also think of few more examples. You maybe from your workplace itself where you can apply machine learning and make your job easy. Right? We will now talk about more formal definition given by Tom Mitchell, right, who is known as father of machine learning. Just give me a moment, right? I'll drink some water. Hello, hope I'm audible. Should we proceed? Are there any doubts? Okay, no doubt. Fine. Okay. Now we have learned enough examples of machine learning, right? What is machine learning? The science and the art of programming computers so that they can learn from data. That is what, in a very simple way, we can explain about machine learning, right? Or another definition that we learned, right, from Arthur Samuel is field of study that gives the computer ability to learn without being explicitly programmed. Another definition that is given by Tom Mitchell, who's known as a father of machine learning, right? Which is more of an engineering oriented definition that algorithms that improve their performance P of some task T with experience C, right? So he defined machine learning with a triplet P, T, and E, where P is the performance of an algorithm at some task T with experience E. Now, what is experience? What is performance, right? What is a task? Let's talk about the email classification, right? Spam or not spam. This is what we wanted to do. So we said we'll feed the data, machine will learn patterns of spam and non-spam, and when given on new emails, it can categorize them, right? So now we have built a model. What do we mean? Now the task here is classifying emails as spam or not spam. Right? Task is T is classifying emails as spam or not spam. What is E? Experience is the data, the historical emails that we said using which we will train our model. And what is P? The performance. Maybe you can say accuracy, right? How accurately it is able to predict the unseen emails, whether they are spam or not spam, right? So more the data, more the experience, more the data, better should be my accuracy of the particular model. So in a traditional programming, right, what we said is we feed data, we feed a program to a computer, and we see the output, right? Input is my data. Like sorting numbers, I'll give a quick sort algorithm, right? And I'll get the sorted output. When it comes to machine learning, you give the data, you give the output. Now, what is this output? Right? And you are actually getting a program. So what happens when I say historical data? Historical data of emails, right? So there is email 1 as E1, email 2 as E2. Who is the sender of this, right? Who and what is the IP address, right? Whether it has words like credit card or not, some features I am extracting from each email. And there will be one feature, right? Spam, right? Which will have values yes or no. So this is what historical data is available with me. I am extracting some features from that email and the label also, which is yes or no. That output is already available with me from historical data. So I'm feeding the data. I am feeding the output, which is a label whether the email was spam or not. I am getting a program out of it, or the patterns or the rules out of it, to categorize the future emails, unseen emails, as spam or not. Does that make sense? Hello? Does that make sense?
Yes, sir.
Okay. Let me take another example. Let's say using machine learning, you want to recognize handwritten digits. Can somebody tell me what is P, what is T, what is E in this case? What is P, what is T, what is E in this case? Quick answer. I want to use a machine learning for recognizing handwritten digits. So what sort of data you require for that? Hello? Have you understood my question? Understood? Okay, what is the answer?
So, sir, for T, it can be the task to classify the characters or the digits from
Hmm.
the input that we have uh, given to the system.
Hmm.
Maybe it can range from 0 to 9 or A to Z.
So let's
Then,
talk about digits only, classify digits. So 0 to
okay,
9. Okay.
0 to 9.
Yeah, good.
Then experience, if we provide a large data set of handwritten samples,
Hmm.
images of handwritten digits, along
Hmm.
with the correct labels.
Correct.
And then for performance, uh, it should give like the accuracy and the rate, error rate, uh, something like this. I'm not sure about performance, but yeah, about experience and T and E, what I've told, I'm sure about it.
Yeah, accuracy is fine as of now. Yeah, later we'll see the other evaluation metrics later on. How accurately it is able to
Yeah,
classify.
like the
Yeah,
percentage of digits correctly recognized.
that's correct. That's correct. Very good. So this is all about handwritten digits, right? Okay. Now somebody might also think why we need machine learning for that. I'll cover that also. We have one more slide for that. So look at this, right? Some examples. Example one, playing a particular game, checkers, right? That is a task that I have. Performance is how many times I will win. Percentage of games won against any arbitrary opponent. What is the experience I have? How many times I've played in the past? Practice game against self. That is my experience, right? So that is what it is. Second example, we already talked about recognizing handwritten words, right? Now it could be digits, it could be alphabets also. So the percentage of the words correctly classified is the performance, and the database of human labeled images with handwritten words is the experience, right? Now, example 3 is the task given is driving on a 4-lane highways using vision sensors, right? And what is the performance? Average distance we are able to travel before there's a human judged error that came in, right? We are talking about autonomous vehicles, self-driving cars, right? So how much distance the car is able to move, right, before a human judged error came, because which car was not able to identify, right? That is a performance. And a sequence of images, right, and steering commands recorded while observing a human driver. Those are the inputs that I'll give to my model, and that will serve as an experience. More the experience, more patterns it will learn, better the performance it should be, right? We have already talked about a spam or genuine emails, right? So the percentage of emails that are correctly classified is the performance of the model, and the database of emails with human given labels will be the experience. Now, if I don't want to use machine learning, right? Traditionally, if I want to do a spam filtering, what can I do, right? I don't want to use machine learning. The traditional approach to spam filtering, what it could be, right? So typically we've seen that okay, these spam filtering emails, right? They uses the phrases or the words which are uh, written as this: credit card, free, amazing. Like these are the words that appear in the, let's say, the subject line or something like that, right? So, basis this observation, if I have to write a traditional spam filtering uh, program, right, the traditional solution would be to manually write a detection algorithm that looks for these frequently occurring terms or the patterns in the emails and then classify them as okay, whether these are genuine or spam, right? We are just writing the rules, and these rules will be used to evaluate, right? That's all. So you developers basically have studied the problem. They have identified some common spam characteristics and then they have written the explicit rules. Like it could be if the email contains certain keywords or pattern, it is a spam. System will then be tested, evaluated, and you can update it until it performs reasonably well, right? So you see there is iteration. You analyze the errors also. Okay, after evaluation, you see, okay, the performance has reached an acceptable level, and then you launch it. Otherwise, not. But what are the key challenges with this approach? What will happen is maybe I can write certain rules, it will achieve the reasonable accuracy also, but this rules, right? Writing rules will be sort of will become very complex, and maybe you could have to come up with large number of rules. It will be a very long list of complex rules that will become very difficult to manage and maintain. Because what may happen is over a period of time, the different patterns in the spam emails may emerge. So developers need to continuously update the rules manually. So again, so it's not like that once that is done, right? So that will work forever. So once there is a new pattern in the spam emails, that has to be studied again. For that also the rules needs to be incorporated, and for every new pattern that is coming in, right? Developers need to study it and write a rule for that. Of course, doing it manually makes it less scalable and less adaptable to even the changing patterns as such. But when it comes to machine learning, right, this is the thing that we are going to follow. We can automate this. So we have studied the problem, right? After studying the problem, we have fed the data, train ML algorithm. Again, this will also be evaluated. If the evaluation or the performance is good, we launch it. Otherwise, if there are still errors, we do certain iteration, change certain, the ML algorithm will be given some feedback and it might change its rules or update its rules, whichever it was missing out. And once the reasonable accuracy or the acceptable accuracy is achieved, we can launch it. Now, what may happen is over a period of time, the rules will change, right? New patterns may emerge. What we can do, the data which we were giving, right? We can update this data. Now the new updated data is fed, and with that updated data we are going to train the ML model. So when we are going to train it with a new updated data, whatever the new rules it can find out from the data, the new patterns it can find out from the data, it will learn, and then again you can evaluate the solution. If it works with reasonable accuracy, launch it, right? Otherwise you need to update the data as well as the rules and so on. The program to train an ML algorithm is much shorter and easier to maintain, right? And it's most likely to be more accurate than writing a set of rules which we were following with the traditional approach. So kind of we can automate this, right? As the new data becomes available, the system can be retrained to adapt to the new spam patterns without any significant human intervention. So with this, the approach becomes scalable as well as robust to the changes over time. So this is the difference between a traditional approach if I follow, right? And well as the machine learning approach if I follow. I hope it makes sense. May I have some input please from you? Are you able to figure out the differences between the two approaches, the traditional one and the machine learning one? Here, I am not doing anything, right? I am just writing a small Python program or a machine learning algorithm, right? Using any other programming language. It could be R, it could be Python, or any other programming language which supports that. So I've written that. Only thing I need to change is new data has come in. I need to feed the new data. Machine will automatically learn. So there's no need to study the data as such again and then come up with the new set of rules which the programmers were doing with the traditional approach. This can be sort of automated with machine learning. That is what they're trying to say. Does it make sense? Should we move ahead? Are there any questions? I'm getting only one response. What about others? No questions at all? Hello? Are people there even? Abhinandan, Pratyusha, Prajwal. Will anybody respond? Anish has left in between. Okay. Shweta, is it clear to you? Ali? I'm not sure now if I'm audible or not. I'm not getting any response. Hello? No doubt, all clear. Okay. See, this is session number 1, right? We should know first in what cases we can apply and what are the different applications. Gradually, we will move to more important and mathematical things as well as programming based, Python based coding as well. Why we apply machine learning on a handwritten digit recognition, right? Now, what you can see here is people write digits differently, right? If I give it to 10 different people, some people may write 7 like this. Some people will write 7 like this with a line. Some people will write 7 like this. Some people will say a 7 like this, right? Some people will write 7 like this. So there are a lot of ways to write 7. You cannot simply say with one pattern I will be able to recognize 7. Similarly, what the sample we have taken here, you see the way the 2 is written. The first 2 is here, second, third, fourth, fifth, sixth. You can see very well the way the 2 is written. If you look at this 3, the way the 3 is written, right? So whatever these highlights we have done, right? Now this looks like a 2, right? But actually it is a 3, right? This also looks like a 2, but actually it is a 3. So even if you look at 5, people will write it differently. How to recognize it? Can I come up with a rule based program and say, okay, this is 5 different types of 5, right? Because if I give it to 100 people, I may get 100 types of 5, right? So the better approach is to go with ML. Let me collect all these patterns of zeros, ones, twos, threes, fours, and fives and feed it to a model. Model will learn patterns of zeros, 1, 2, 5, 3, 4, 5, 6, 7, 8, 9. And then once you give it an unseen data, it will be able to classify which particular digit it is, right? So that's an example of a machine learning task again. We have talked about it earlier, but this is why we use machine learning, because it can be written in different ways by different people. Only coming up with a program with one set of patterns may not be sufficient. So we use machine learning approach. With machine learning, we train a model with different kinds of inputs of a particular digit. Once the model is trained, you can use it, deploy it to predict it for unseen data. So these are some of the tasks which are best solved by the machine learning algorithm, recognizing patterns in the images, data, right? Facial identities, handwritten or spoken words, medical images. Recognizing anomalies in the structured data set. What is anomaly? What is anomaly? This is a very common word. Shreya, can you explain what is anomaly? What is the English meaning? When you do have duplicate data, okay. Anything else? Are people there even? Vasu? Something different. That's very simple meaning. Abnormal, right? Which behaves differently from the normal behavior, right? That is abnormal. If I say now in the summer season, the temperature becomes below 10 degree, right? That's an abnormal thing, right? Recognizing anomalies in the structured data set. Now, maybe possible that, okay, uh, normally I make credit card transactions from, let's say, 0 to 10,000. Suddenly there is a transaction of 50,000 with my credit card. That's anomaly, right? Unusual credit card transactions. Maybe I'm using it in India and suddenly I see, okay, like, okay, there's one transaction that happened in, let's say, in a different country. Kind of an outlier. Yeah, you can say that if you know that word. Yes. So these could be some unusual data, right? Unusual patterns that exist within the data assets. Prediction from time series data. Future stock prices or currency exchange rate. This can also be best solved by the machine learning problem, right? Time series data. Generating new patterns, generating images, motion sequences and all. Gen AI is doing that, right? Now, what do you what you can interpret from this chart? Machine learning helps human learning. What does it mean? What does it mean? See, you have to be involved here so that some learning can happen, right? It's very, very basic session today. If you participate well and show some demonstration, maybe I can move little more faster. You said you don't have any prior experience with machine learning. With ML prediction, decision making by considering factors, humans also learn and evolve about trends. Okay, good. That's very, very good overall. So what typically we are doing, right? We are having lots of data, right? I don't know what kind of patterns are hidden within the data. But data will speak whatever it is, right? And many companies are moving towards data-driven decision making. So whatever data will say, basis that we are going to take a call. So there is one common sense, right, which we feel that okay, this cannot happen, right? This is not expected. Many people will do some speculation that this cannot happen. But when you look at the historical data and do some kind of analysis, you suddenly come across unsuspected correlations, right? Or certain trends that gives you the better understanding, right? Typically, this happens when you do a lot of data mining, apply data mining techniques. Data mining means you are, I mean, you can use machine learning within data mining also. So you apply ML techniques to dig into large amount of data that help you to discover certain patterns within the data. Now, what we typically do within one data mining task is association rule mining. That is also known as market basket analysis. All of you have visited some grocery store? Yes or no? Have you visited some grocery store? Or any supermart? Yes. What do you typically do? You take your cart, you keep on adding some items to the cart, you go to the billing counter and you make your payment, you collect your products which you want to buy and come out. Yes or no? This is typically we do, right? And imagine there are 100 or 1,000 customers coming to that particular store or supermart and doing the same thing, right? So whatever each customer buys in a one particular visit, right? That is a one considered as one transaction. Let's say customer C1 has bought items I1, I2, I3. I'm just giving a general names, right? Customer C2 has bought I3 and I5, right? Customer C3 has bought I2 and I3. So in this way, we are tracking what are the items purchased by a particular customer in a one transaction. Each customer visiting a store, buying some product, making a payment, that is one transaction. So in each transaction, we are just trying to find out how many, which items the customer has purchased. When I'll have some data of these items, right, or these transactions, I can find out which two or which three items are frequently purchased together, right? And if I say, okay, I1 implies I2. This is one association rule, right? This is what an outcome we found, meaning that if somebody has bought an item I1, he's likely to buy an item I2. That is what it means. Now, when I have the historical data of these transactions, right, using this, I can learn, or machine can learn whether the purchase of I1 influences I2 or not. Likewise, if you see, people generally buy bread, butter together, right? So if from the data, if I am able to figure it out, okay, if somebody has bought a bread, he's likely to buy a butter. If somebody has bought a toothpaste, he is likely to buy a brush, right? Many times you see a promotional offers on them also bundled together. How these things come up? They analyze the data. Once they analyze the data, okay, these two things are being purchased together. Let me put a promotional offer, or let me plan the layout of a store in a better way so that these things are put together. A lot of things come up with machine learning, right? When you feed this data, through this data, right, machine learns certain patterns, and maybe one of the patterns could be this purchase of a one particular item influences other, right? Purchase of a bread influences the purchase of butter, or purchase of a toothpaste influences the purchase of a toothbrush also, right? So these are, you might also feel that okay, these are some general correlations, like okay, bread and butter, fine, it looks okay, toothpaste and brush, okay, right? Maybe one of the odd correlations may come is okay, let's say tennis ball, purchase of a tennis ball employs purchase of a toothbrush. Now this may look like okay, uh, not a very sensible correlation, that okay, somebody is going to buy a tennis ball, is going to buy a toothbrush, right? But maybe a possibility that the customers who have come to that store have done that, and that's what data speaks, right? If data speaks, and this will be the correlation that will be coming out, this will be the association rule. So some unsuspected or new trends may be an outcome of applying machine learning techniques, right? So this kind of a correlation may eventually come out. And this was a very popular story, beer diaper story it is known as. In one of the stores in US, this kind of correlation was found. People who were buying beer, they were also buying diaper. Although there's no such correlation, sensible correlation that do exist, right? But that was found. That was found in one of the very popular supermarket stores in within the US. And this is a very popular story. You can Google it out, beer diaper story. So something unsuspected things may come up when you learn from the data. And that is what is adding to the human learning also. Do not go by some sensible things. Let us see what data speaks. I hope it makes sense. Yes or no? When to use machine learning? Very simple thing. We have now gained some basic knowledge on machine learning, on where it can be employed, how it can be employed, right? What is the role of the input data, and so on. Problems for which existing solutions require a lot of hand tuning or a long list of rules, that are the potential problems for using the machine learning. Second is complex problems for which we do not have a very good solution with the traditional approaches. And where the environment keeps on changing, those are also, when I say environment, right, the patterns or the rules that you might have programmed in your you have written in your program will not be sufficient when something gets changed, right? For those changing environments, like I gave you an example of email spam, later on the structure of spam email changes. So what you will do then? Get insights about complex problems and large amounts of data. You want to do that, then go with machine learning. Don't use machine learning for over simplistic problems. For deterministic problems, do not use machine learning, right? Where you do not have a very much deterministic algorithm that you can write for a particular problem, go and use machine learning. When you feed a lot of data, the accuracy is likely, or the performance is likely to improve for the machine learning model. Now, where does ML fit in, right? You look at any field, applied maths, as I said, right? It borrows principle from that optimization, linear algebra, right? Then statistics also, computer science, algorithm design, complexity analysis, and all those things will be also sort of, you need to know that in order to apply that machine learning. Then the psychology part, physiology part, biology of learning, inspiring paradigms, those neural networks specifically, that also comes under machine learning, the way the human learns, right? Then new challenges, the kind of applications that are coming in, right? That also enforces or suggests the use of machine learning as such. So wherever there is applied maths, right, where you want to do some forecasting estimation, right, using statistics, where you want to sort of implement the learning the way the biological systems learns, right, specifically neural networks, and the applications with new challenges that are coming in all such cases we can use machine learning. And these are the domains, application domains, where we can use it. So you can go through it. I'll not go to each one of these word by word, but yes, applications domain, internet, computational biology, finance, e-commerce, space exploration, robotics, information extraction, also social networks, software engineering, also system management, creative arts. For every, now you name any domain, right, that domain machine learning is applicable, right? Even nowadays in manufacturing also, machine learning is applicable. People are manufacturing some certain products, right? So there also the machine learning is applicable, because there could be some predictions that we want to make. There are components which are helping us. Some machine is there which is helping us to fabricate some components, right? But that machine will have some failure time. I want to predict the failure rate, or I want to predict the failure of a machine. How do I do that? ML is the solution for that. Now, aircraft companies also use one prediction. They also want to solve one prediction problem. They want to predict the remaining life of an aircraft, right? So again, there are a lot of features within that. You cannot simply come up with a program and say, okay, this is say fine, then okay, the remaining life is good. No, lot of features are there, so you need to have a lot of historical data, train a model, and then it will predict what is the remaining life of an aircraft as such, right? In finance, how it can be used, maybe I want to find out, let's say, the people who will default in loan repayment. I want to find out that. I must have the historical data with me, people who have already defaulted while repaying the loan. Once that data is available with me, I can train a model. Once I achieve the reasonable accuracy or the performance which I am looking forward to, I can deploy the model. And now further, uh, looking at some demographics of a particular borrower, we can predict whether he is likely to default or not. That is how it can be used in finance. E-commerce, as I mentioned, market basket analysis, one example, right? Space exploration, robotics, right? Robotics, there are algorithms like Ant Colony and all those things where um, this AI is has used even in robotics as well. We can train a robot, right? Information extraction, very, very important part. Social networks within Facebook and others, how you will use it, right? So these are all the application areas. You can study a little more on them, right? Explore on them and then see. These are examples related to the classification problems, right? Assign object or event to one of the given finite set of categories. That is a classification problem. When I say medical diagnosis, right? Medical diagnosis, what it says is whether you have a particular disease or not. Yes, no kind of a thing, right? Or if there are multiple categories within it, like if I say fatty liver, grade 1, grade 2, grade 3 and all, that becomes a multi-class classification thing. If there are two classes, that's a binary class classification, right? Binary classification. Credit card applications or transactions, right? You want to detect frauds, right? So that could be again a classification problem. Fraud detection in e-commerce is again a classification, whether a particular transaction or whether the particular transaction is a fraud or not. Bomb detection in network packets, detected or not, again a yes no thing. Spam filtering, yes no classification. Recommended articles in newspapers, again a classification. Recommended books, yes or no, right? Financial investments, DNA sequences, spoken words, handwritten letters, astronomical images. You just want to classify them into one or the other categories. That's why they are classification problems, where you are trying to predict from a discrete set of classes. That's a classification problem. There are problems where you want to predict a numeric feature. Those are regression, right? So performing actions in an environment in order to achieve a goal, planning, control, and problem solving. Look at this: playing checkers, chess, or any other game, right? Balancing a pole, driving a car or a jeep, flying a plane, helicopter, or a rocket, controlling an elevator, controlling a character in a video game, controlling a mobile robot. So all these things we can again use machine learning to solve these. How? We will see on some of these, right? Not on all of this. So how do we do a speech recognition, automatic speech recognition? How does it happen? Now a lot of automated systems are there for speech recognition, right? So voice as such in the form of waves is fed, right? What happens typically is you extract the features from the voice. When you say features, those will form a kind of a data set, right? You feed it to the neural network, right? This is what we are feeding it to the neural network after feature extraction. These are the voice modulations. We are feeding it to the neural network. There's a decoder, there's a transducer, as well as the language model, which will recognize the speech like, hi, how are you? So if this is fed, right? So this is the wave for that, and this is how you recognize it, right? So what ML is used? It is used to predict the phone states from the sound spectrogram, right? We have given the input. It is able to extract the features. ML is predicting or looking at those features what the word could be, right? So we need to train the model, right? And neural network is something where a lot of computations happen, right? We have one portion dedicated to neural network. We'll learn in that what exactly the neural network is. But you say in normal machine learning and then this neural network, there's a lot of computations, though it is a part of ML, but a lot of computations will happen in layers. And the term used for that is sometimes deep learning. So what we have got here is so many hidden layers we are using within neural network, right? If I use one hidden layer, means less of the computation. This is the error rate that I am getting. If I'm using two hidden layers, reduced, three hidden layers, further reduced, and so on. If I use 12 hidden layers, 10 to 12, right? So you can see 10.9, 11, 11.1. So error rate is getting reduced as you are increasing the hidden layers to a certain point. After that, again it starts bit increasing, right? So this is taken from this paper, rectified linear units for speech recognition, right? The baseline is Gaussian mixture model where the performance is 15.4%, right? While if you look at this with hidden layers, it is a remarkable achievement overall, right? Only this error rate is 10.9% with 8 hidden layers. And when you increase the layers, right, the computations also increases. It means the training time will increase. That is what it means. Okay, so I am going to stop here. It's already 11, right? So some of these things we will talk in the next session, right? Different types and all. Okay, next time I think we've talked a lot about the theory, a lot more details about now classification and regression we are going to talk about in the next session. Some terminology we will learn. Right, first 2-3 sessions will be largely theory sessions, right? And then we will support it with some demonstrations later. So these are all whatever the images that are being shown, right? So you can see that some or the other way we are going to apply machine learning or the deep learning techniques here, right? Impact of deep learning in the speech technology. You can see this Siri and Google now, how they have revolutionized this particular industry as such, speech recognition. Now, if I have to answer visual questions also, I can answer it using ML, right? What color are her eyes? What is the statues made of? How many slices of pizza are there? Is this a vegetarian pizza or non-veg? So from the images only we can do this kind of a classification, right? But provided we have a relevant training data for that, right? That's all from my end today, right? I'm going to stop here, and once the course page is mapped, I'll make the handout available. And these slides I'll put it in Teams for right now for your reference as such. Study, right? This course is interesting, very practical, and when you study this, right, you will be able to find out use cases definitely at your workplace, and one kind of assignment we will do from your workplace only.